Hello everyone, we're going to talk about the Statistic Process Control SPC chart. This is a very popular, famous chart to control the process and even the equipment engineer for using to control the equipment parameters. For example, this is a typical chart. We have the median bar is X bar, or we call it target, this line. For example, this chart for control the etching rate. Target we order to set up to 50, the S bar 50. Then after calculus, the sigma equal to 5, so 1 plus sigma would be 50 plus 5 to 55, and plus 2 sigma would be 60, and 3 sigma 65, and minus 1 sigma 45, minus 2 40, and minus 3 35. So if we have the target for the etching rate 50, the sigma after calculus equal to 5, we have these values fit the SPC chart. Is, for example, very common use for two situations. One situation, we use it for control deposition rate, or control etching rate, or control photoresist thickness, and so on. In this status, in this case, the LCL low control limit will not be 0. The 3 sigma, call it low control limit line, and 3 sigma positive, this is up control limit line. In this case, for deposition rate, etching rate, the low control limit line normally will not equal 0. Is a good control area X bar, positive or minus within 2 sigma. That means within 2 sigma here. So you can see, if we have the monitor point value, for example, this value within 2 sigma, positive or minus within 2 sigma, and this point within 1 sigma, also within 2 sigma, this point within 2 sigma, within positive and negative 2 sigma. It's a good control. You can see the monitor value here, 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 good. Here is good. Here is good. Here good, 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 good. All within 2 sigma. And the warning point X bar, two sigma to the 3 sigma area. Within 3 sigma, just this point. This point is out minus 2 sigma, but within 3 sigma, this point. This is a warning point. Usually, if a machine measured etching rate, this point, for example, 43 etching rate is between the 3 sigma 33 and the 2 sigma 40. This is this case. Warning. At this situation, the product wafer yield could be good, but it warning for engineer to check it out and to investigate this issue. And some fab treat this area 2 sigma and 3 sigma until 3 sigma. This area 2 sigma until 3 sigma. Some fab has serious treatment. For example, hold the product wafer lot during this period to check and stop the equipment to check. And over 3 sigma S bar, positive or negative 3 sigma over. The 3 sigma, this line, we call it up control limit. 3 sigma, this line, we call it low control limit. If it over, for example, this point, over minus 3 sigma, the process will hold the process lot to check the wafer and stop the equipment and contact to equipment engineer to check the equipment, and the process engineer check the monitor SOP. Maybe the false alarm for the MOI or dummy wafer issue. So you can select the 2 sigma area. We want the H rate controlled inside the 2 sigma area, and over 2 sigma area to the 3 sigma area. It's warning, and over 3 sigma to the low or up control limit is a bad. We got to do something action. This is a SPC chart using, and the other case, particle adding value or defect value and so on. The low control limit equals 0. The particle adding we monitor. 0 is the best. It shows that no particle pollution in this case, and defect equal to 0 is best, no defect. So the chart for control particle and the defect, the low control limit would be 0. The good control X bar within positive 2 sigma. A warning X bar 3 sigma within, and the whole lot X bar plus 3 sigma over. Just similar to the other using, but the low control limit would be 0. We use this control table to control the process, and we want the monitor or the particle or every kind result under control at 2 sigma area and not over 2 sigma, even not over the 3 sigma. 3 sigma is our control limit. We are going to introduce the SPC chart using later. This is the basic knowledge for the SPC chart. And you asking about 1 sigma, no use for this chart. I can say that if your chart like this, all inside positive and negative 1 sigma is very good. Even the system will tighten your spec to make the sigma smaller and let you control the table to become very difficult to maintain it. So if your value just under control very perfectly, you got to tighten your sigma value to make the scale smaller. Then you can see the edge very detailed, but it becomes more difficult to maintain your good performance with the SPC chart. This is the 1 sigma function. I shall see you next time.